Welcome back. This is Nick Agram. Operations on algebraic expressions, which is under rational algebraic expressions. I need to point that out because you might expect that I will be discussing the normal algebraic expressions, but this is irrational expressions. Okay, multiplication is the first that I'm going to discuss. For example, we have the rule is that if we have A divided by B multiplied by C divided by D, the rule is that we multiply the numerators AC divided by the denominators BD. So for example, you have in your page 89 in your book, the examples I'm not going to discuss. You can read them and then understand them. But the exercises says T10uv squared divided by 3xy squared multiplied by 6x squared y squared divided by 5u squared v squared. Following, we have AC, we have T10 uv squared 10 times 6 I am thinking, okay, and then we have times 6x squared y squared. It's all right. It's better to do this way. And then we have 3xy squared multiplied by 5u squared v squared. And then expand if you can. For example, 10 can be factored into 5 times 2 and then uv squared. 6 can be factored by 3 times 2 x squared y squared, or x squared can be factored also into x times x, and then y squared, it doesn't matter. Why? Because we have y squared in the denominator. I have a problem with that. So we have 3xy squared times 5u times u times v squared. It doesn't matter, you don't need to factor that. Now we are ready to cancel because we factored already. 5 and 5 will be 1, 3 and 3 will be 1, x and x will be 1, y squared, that is y squared, and y squared will be 1. U and u will be 1, v squared and v squared will be 1. What remains is 5 times 2, and 2 times 2 is 4, x. And then we have u. It's only u. Double check my answer. 2 times 2 uv squared. Oh, it's only u. That is remain in the denominator. Okay. Let's try number 2. Number 2 says a squared minus b squared divided by 2ab multiplied by a squared divided by a minus b. The numerator here, as you can see, is a difference of 2 squares. So there, the factor is sum and difference of 2 terms. We have a plus b, a minus b, multiplied by, I can factor that, a times a instead, divided by 2ab multiplied by a minus b. As you can see, I am ready to, that is a times a. I am ready to cancel because it's all everything is in factor form. A minus b, I can cancel that, and then a will be 1 also. So the remaining is a times a plus b divided by 2b. Number 3. X squared minus 3x divided by x squared plus 3x minus 10 multiplied by x squared minus 4. Then I have x squared minus x minus 6. Factoring, we have x as the common factor. We have x minus 3 divided by, we have, I hope, 5 and 2. Exactly. We have x plus 5 and x minus 2. Because 5 times negative 2 is negative 10. And 5 minus 2 is positive 3. Multiplied by, I will put it here now, sum of 2 squares. So we have sum and difference of 2 terms, x minus 2, x plus 2, x minus 2. And then the last, we have x. Can I? 3 and 2. That's 6. Oh, negative 3 and negative 2. And positive 2, I should say. Because negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1. Good. Now we are ready to cancel. X plus 2 will be 1. X minus 3, this is 3, will be 1. X minus 2 will be 1. And on the only term that remains in the numerator is x plus 5. I think I will give you the chance to solve number 4 and 5 instead. Let's see if I have some more to give you in my other references. It's almost the same. Not much. You can try this. Other examples. You can try this. X squared plus 4x minus 5 divided by 3x plus 18 multiplied by 2x minus 1 divided by x plus 5. Okay, then we have x 5, that is 5, that is 1. We need positive, so this plus 5 minus 1 divided by 3 is the common factor. We have x plus 6. Let's see. And then we have 2x minus 1. And then we have x plus 5. Then we need to cancel. And our answer will be x minus 1, 2x minus 1 divided by 3 times x plus 6. It's pretty much the same. So, see you next time. On my next video, I will be discussing rational expressions. What's the name again? I always forget the name. The name will be operations on algebraic expressions. Operations on algebraic expression. But I will be concentrating on division. Okay, see you around. Thank you for watching.